Hi, welcome to Electrical Info YouTube channel. Subscribe our channel and share. Today we learn about phase failure relay, single phasing preventer. In a three-phase motor, when under running conditions, one of the three fuses blows and power to the motor is supplied by the remaining two phases. The motor is said to be running on single phasing condition. To maintain the same power input to the motor during single phasing, the current in the remaining two phases will increase by 1.73 times. If the motor is lightly loaded, currents in healthy phases will not increase beyond the full rated current setting on the overload relay. Thus, overload relay will not be able to detect single phasing when the motor is lightly loaded. For example, consider a 10 P motor with rated current of 14 amps and overload relay setting at 10 amps. At a particular load, let the motor be drawing a current of 5 amps. If one of the fuses blows out or a conductor breaks, current in the two phases will become 5 times 1.73 equals 8.65 amps, which is much below the relay setting of 10 amps. Therefore, the motor will continue running under single phasing. Single phasing of the motor results in superposition of negative sequence of current flow over the positive sequence through the motor windings. These negative sequence currents are of double frequency as compared to positive sequence currents and produce a torque which is opposite to that produced by positive sequence currents. As the iron losses are proportional to frequency, the negative sequence currents cause higher iron losses and therefore greater heating of the rotor. Rotor heating is further increased due to skin effect, due to higher frequency. Undetected heating can damage the rotor, and due to convection, stator windings also. This excessive heat can finally cause burnout of the motor. To avoid failure of the motor due to single phasing, phase failure relay, or commercially known as single phase preventer, is used in the motor circuit as shown in Fig. 2.26. As shown in the figure, the relay is connected in the incoming supply phases. The control contact, 11 to 12, is connected in series with the contactor coil circuit. If the starting time of the motor is more, to avoid undesirable tripping, the control contact should be bypassed during starting. Brief description of a relay which works on the basis of detection of negative sequence current is explained as follows. The relay has two built-in current transformers which sense currents of the motor. The secondary of the CTs feeds a negative sequence filter. The output from this filter is proportional to the negative sequence component of currents. This output is fed to a sensor which detects the level of negative sequence components of current and thus trips the motor starter by opening its control contact. These relays are designed for different ratings of motors up to 20 HP. For motors above 20 HP, a relay rated for a 3 HP motor can be used by using current transformers on the lines as shown in Fig. 2.26. The CTs should have a secondary current of 5 amps. The primary current should correspond to full rated current of the motor. The two secondaries are connected to two phases of the relay. The control contact is used as usual in series with the contactor coil. Thanks for watching. Subscribe our channel.